Hello, I'd like to continue where I left off on the last video about implementing a sorted list. Now, that time we were looking at two different possible implementations, by vector and by array. I brought up here the implementation as a vector, and two things I want to know. I've added include algorithm and include seedtime. The reason I added include algorithm is because you can get the real fancy simple sort by that method. It is a fast sort, faster than we can write. I may have said that last time, but I want to emphasize it again. It's one of those algorithms that comes with the machine. And the star dot begin with the parentheses and the star dot in with the parentheses, those are the first and one past the last items in the vector. Now I also wanted to time this and see how long it would take. I've given you one way to time it with Chromo, but it turns out that one still counts some of the waiting time. So instead, I went to the web and found, I think, the only one in a list of 8 that does only the execution time. It exists on seedtime, and for us, it's very, very simple. All we do is at the beginning of whatever we want to time, we create a variable called cstart, or create a variable, any name you want. I use cstart, and it's a type clock underscore t. And all I put into it is clock, parentheses. What that does is more or less store the current time. But it's a clock that doesn't run on wall time. It runs on basically how long when the program is executing, as near as I can tell. When you get to the end of whatever you want to time, create a new variable. I called it c_in. Give it the same value because now we want the clock time here. And then to get what you want, do the duration, do some variable equals cn minus c start divided by clocks per second. Now remember, the difference is the number of clocks we got, of clock ticks, and clocks per second is how many there are in 1 second. But I don't want seconds, I want microseconds. So I guess I got milliseconds. I divide it by 1,000. So I got thousandth of a second in what I put here. Now, that's one. I want you to notice that this main, I want you to look at it, because I'm not going to change it in the other implementations. So now I'm going to bring in the implementation for an array. And you'll see the same seedtime. And actually, again, you'll see down here. Now what did I do? Well, I can't open it. I did it. I got exactly the same main line. This time, when you want to do the sorting, you have to arrange it a little differently. That's probably the only, no, pardon me, I didn't have to, because I did the sorting up in the class. When I did the read in bulk up here, that's where I did the sort. So again, it's hidden from the user. Finally, I wrote a version using linked list, and this time is a little different than the versions you've seen, because what I did was I put the reading and the sorting inside the functions inside the class. So read in bulk reads them in and does the add to list, which keeps it sorted. And further down here, add to list is also part of the class, and if you look at it, it brings in everything, puts them in. The way I wrote it, I could not use any built-in way of sorting the list, so I had to do it myself. This is exactly the same main program. So the point of all of this is that we have 3 implementations that all do the same thing as far as the user is concerned. If all goes well, which I think it did in this case, I've got to get this over there where you can see it. Now that'll do. I have all 3 of them in one Word document, which I will post in a few minutes. You can run these to see what the time differences are. The first 2 will come out very close to one another. The last one will be much different, the linked list. Now, this is for the create and the making of the ordered list. The question now is, how do they work when we're searching for the ordered list? And that'll be something I'll be talking about in the next few days. But I wanted you to see, as the book sort of mentions, that you can take the same user interface, which is the main line here, and behind it have 3 different implementations, and some of them are faster than the other. So that's where I'm going to end now. You may get another video either tonight or tomorrow. We'll see what happens. Bye now.